Hey, welcome back to Gaming for Tokens. I'm Marshall, and in this episode, we're going to be talking a little bit about how to read inputs given to the game by your player, so key presses and mouse buttons and that kind of thing. The first thing that I've started with is a blank Unity scene here in the same project I've been using for all of the videos, but the important thing is that there's nothing in the scene. And to get started, I'm going to go ahead and go to Edit, Project Settings, and Input. This will bring up the Input Manager in the Inspector window, because again, you are, harkening back to the first video, I think, you are grabbing the Input Manager file and inspecting that in the Inspector, just like you would a camera, for example, that comes up with the Inspector. You're grabbing the input file in the project directory. So in here, what we're seeing is that we have 15 different inputs. This is kind of like the arrays from the last couple videos. It's, I think, exactly how this is read. So if we change this to 16, we would get another input at the bottom, and it duplicates the input previous to it. So we have 2 jumps now. We actually have 3 jumps, but anyway, so the inputs that we come with by default are vertical, horizontal, fire 1, fire 2, fire 3, mouse X, mouse Y, so on, so on, so on. So if we open up horizontal, we can kind of see what we what the input is reading. So it has a descriptive thing that isn't being used. I don't think that's being used in really any of these. I don't really know what that's for. I've never actually seen it being used, but it says name of the negative button present for the user from setup. So in Unity projects, from I believe what this is, in Unity projects, when you launch them, sometimes they have like the input window. This is just a description of what the key is. Most of the time the name does the trick for it, so I have a feeling that that's why they're never used. Anyway, point is, those are descriptions for your player if they want to see what the inputs are, what they're used for. Not really that important for what we'll be doing today. The negative input button, so this is the horizontal one. If you look at the, if you think about this instead of a horizontal as forward, backward, the negative button would be back and the positive button would be forward. If that makes sense. In this particular instance, left and right, because left is negative on the X, if you look. So the red arrow always points to the positive direction. So right is positive and left is negative. That's basically what they're saying in the input manager, which makes sense as far as 3D space is concerned. So negative is left, positive is right. Also, alt negative is A, so that's left on WASD, W-A-S-D, and positive is D, that makes sense, that's right. So if you're familiar with first-person shooters or any kind of game that uses WASD keys, then you know exactly why that makes sense. If not, then most games use WASD for your left hand for movement. I suggest you go play some games and figure that out for yourself. But yeah, basically that's what that means. A lot of these things have pretty good tooltips, like gravity, for example. Speed in units at the output value falls toward neutral. So the way to think about this is when you push, like, so D is our positive button. The input is a float value from -1 to +1 most of the time. So if you happen to push D, then it goes to +1 over a certain amount of time. And that amount of time is, I believe, the sensitivity, in units per second. So within the first second, the input value goes from 0 to 3. That's not necessarily going to be true because it only goes to 1, but that tells you how fast it goes, basically. So the faster this goes, the faster it's going to get there, with a certain cap probably that is dependent on frame rate. But anyway, gravity is how fast it goes back the opposite direction. So if the sensitivity and gravity are the same, then it's going to effectively be instant. Well, if the sensitivity is instant, then the gravity will also be instant. So for key presses, this makes a lot of sense, because if you hit D, you want to go right, and if you let go of D, you don't want to go right anymore. If you decrease the gravity to like 0.125, then that would mean that it would there'd essentially be an acceleration. There would be like I'm pushing D to go right, and then I let go of D, and then I slow to a stop. A lot of the time, that makes for what is known as floaty controls. And depending on the type of thing that you're controlling, if it's a first-person shooter, for example, you really don't want floaty controls. Same thing with a platformer. You want to be able to go when you want to go and stop when you want to stop. And that's really, really important. The dead zone is specifically for analog devices like joysticks and that sort of thing. It's the amount of input that is ignored from 0 to whatever the value is in both the positive and negative direction. So if this is 0.001, a lot of the time I remember way back when Halo was new, the first Halo for the original Xbox, we played the hell out of it so much that our controllers started going bad, and the joysticks would do what is commonly known, I guess, as wandering. You'd have a wandering stick, and it would you could set the controller on the table, and your character would still keep moving a little bit. That is negated with a dead zone. So if you increase this dead zone, it's like the joystick was sticking a little bit, so it was still giving input even though there was no input being given by the player. The joystick was giving the input, if that makes sense. So this is for that. It's a compensator for the flaws in the physical joystick itself. So the higher this is, the higher the area that it will ignore from the joystick is. If you decrease this, then you could have issues. But if you're seeing input arbitrarily being sent when there shouldn't be, you may want to consider increasing the dead zone on your input, if that makes sense. So the sensitivity, I already kind of went over that. It's the inverse of gravity. It's how fast the input is read rather than how fast it goes away. I don't know. It's hard to describe. But basically, if you push a button, how reactive is that to being fully read as an input? For example, in a joystick, if you push the joystick just a little bit, then it's obviously not going to go to 1. It's going to go to like 0.25 or something like that, as far as the intensity of the input, because it's kind of like an intensity gauge. So if you're barely pushing the joystick at all, then the input's barely going to go up. But how fast it goes up to that point is the sensitivity. Snapping is if we're pushing D and then we push A, do we immediately go to 0 to accelerate to A? So if you remember correctly, sensitivity is the acceleration to the maximum input value, or the current input value, whatever that is. And then gravity is the deceleration technically the acceleration. Deceleration isn't a word, but you get what I'm saying. The acceleration towards 0 when there is no input. Well, what happens if you push the negative input to whatever input we are currently at? So if we're holding D, we let go and push A, does it have to go all the way to 0 before we start accelerating to A? Because that seems kind of floaty and weird. So Snap says that no, if you push A, then we immediately go to 0 and start accelerating to A. It's kind of a nice thing for like Twitch movement. That's why it's checked by default in the horizontal and vertical and all the controls and stuff in here, because it's really, really great for Twitch movement. It's I'm going left, now I'm going right, done. Instead of it being like I'm going left and now I have to slow down and now I can start going left, or going right, now I can slow down and start going left. Sometimes you want that, sometimes you don't. In like a racing game, that seems like it would make a lot of sense, because you have to like, obviously there's weight, there's inertia, so you have to kind of like, slow down going the direction you're going in order to go another direction. That makes a lot of sense. But for like a first-person shooter, it's going to feel really crappy. And then there's obviously inversion. So like if you wanted to invert your Y, that happens in a lot of flight games and stuff like that, you just check that box. And these are the types. The types are, what kind of input is this? Is this a key or mouse button? Sure. Is it a joystick axis? Sure. Which, by the way, if you click off the input menu, it goes away. That's why I keep having to open it again. Anyway, so that's that. The axis is which axis on the joystick is it. Being this is a key or mouse button, that's practically ignored. And then the joystick number. So if you want to do a like 4-player game, then it's kind of a pain, because you have to set up all of these inputs, and then you have to set them all up again for a different joystick, and then again for the third, and then again for the fourth, all up to how many players you want to have. As far as I know, there isn't really a streamlined way of doing that. There absolutely should be, but there isn't. What I've done is I've just started off with 0, or well, one input, and then you can kind of, because remember, if you duplicate this, then you can kind of, it duplicates, or if you extend the list, it duplicates the last thing in the list. So you can kind of get away with clearing out your input menu entirely, starting with a single input, and then duplicating that, changing the joystick, duplicating it, changing the joystick, duplicating it, changing the joystick. What that means is you have to make your entire input menu from scratch, and it's kind of an advanced thing to do, but it saves a lot of time if that's you're making a multiplayer game. And keep in mind, these are only multiplayer, like local multiplayer. These aren't like network multiplayer. Network multiplayer, everything is going to use like joystick 1, because each computer is each build is reading from joystick 1. It's not reading from joystick 2 on another computer. That'd be really weird. But anyway, so that's kind of advanced stuff. But anyway, so that's kind of what horizontal is. Fire 1 is a different thing. This is a key press, basically. So this is left, right, which are the arrow keys, and A and D, which are the WASD keys for being able to move around. And actually, it's also really important that it uses left, right, and A and D. A lot of people that hear that are going to be hardcore gamers are like, who the hell would use the arrow keys? Left-handed people would use the arrow keys. So you have to stay accessible, remember that, and input's one of those first things that you're going to be learning about accessibility. If someone picks up your game and doesn't understand the controls, that's not their fault, that's your fault. You're the designer, and you should suck that up and figure it out. So again, make sure that it's accessible, make sure that left, right, and A and D are used for your horizontal movement. By default they are, so it shouldn't be that big of a deal. Fire 1 is a mouse button press, but it also has a key press, because for some reason Unity decides to use left alt as Fire 1 as well, which goes directly against the accessibility thing I just said. But anyway, because it should be just, or left control, sorry. It should just be control in general. It should be either one, but whatever. Because it also uses mouse button 0. So mouse 0, that's going to be left mouse, if you think. So it's, again, with the array counting, it's the first thing is actually 0, and then the second is actually 1. So mouse 0 is left mouse, and mouse 2 is mouse 1. So it's kind of weird that Fire 1 is mouse 0 and Fire 2 is mouse 1, but you'll get used to that. It's also left control, and then I believe Fire 2 is left alt, so that's kind of weird. I don't know, I never really understood why that was the case, but I guess it's so you can play your entire game with the keyboard if you really wanted to. I don't know why. Again, most of this stuff doesn't really... gravity, you'll notice, is at 1,000. That's really high compared to this. I'm not exactly 100% positive on that one, I guess because you want a mouse click to be really, really responsive. So that's why the sensitivity and gravity are both that. I feel like 3 is also really responsive, but maybe I'm just crazy. I don't know. It has the same dead zone as before because a mouse button shouldn't really require a dead zone. It's either yes or a no. It's kind of like a Boolean. It's either it's down or it's not. It's not like for example, this horizontal, which is different than this horizontal. This horizontal is keys. This one is joystick, so it's labeled as a joystick. Just like Fire 1 is labeled as a key or mouse button still. This is labeled as the joystick axis, which means that this has a varying degree of like, this can be 0.125, this can be like 0.5, whatever. The horizontal up here can't necessarily be. It's either going to be yes or no because it's the button's down or the button's not. But this is a joystick inputs are special. So this by default is getting motion from all joysticks. So if you hooked up 3 controllers to it, all 3 of them would be able to control the same input, which is kind of strange, but that's just the way it works by default so that you can prototype easier, I guess. You'll also notice that none of this stuff is here because the only thing it's using is the x-axis on here, which was being ignored on everything else. But on this particular one, it is being used. That's all it's using. It's not using any of the positive or negative inputs or any of that crap. It's just using this. And the sensitivity is 1 and the gravity is 0. So you may be asking yourself, but wait, doesn't that mean that it's not going to go down? No. It works because I think there's a special case for if it is 0. But I'm not 100% positive as to why gravity being 0 works. It does. I believe it's because there's a special case when it's at 0 and it automatically goes down if it is set to 0. I believe that's the case. So, because gravity, again, is the return to neutral. And as it says here, the speed in units per second that the output value falls toward neutral when the device is at rest. I believe if it's 0, then it just automatically does it because it can't not be going down. If that makes sense at all, I hope that does. But the sensitivity is still at 1, so if you wanted your joysticks to be more sensitive, you could increase this to like 3 or 2, and essentially 1 is a 100% sensitive. And again, this is a float value, so you can do like 1.25. And there's your inversion, your snap, and all that stuff that I talked about before. Snap on a joystick isn't exactly what you want, because again, if you have your gravity at 0, then as soon as you let go of the joystick, it's going to snap back to 0 already. So you don't necessarily need to have a snap value. It sounds kind of strange and counterintuitive, like why does a snap value even exist? Well, these are just, having more ways to do something is better than not having enough ways to do something. So I think that's the mentality with the input system. I'll be the first to admit that the input system is kind of clunky and kind of weird to understand. It took me a little while to really understand how everything worked in here, and I still don't really understand it entirely. But that is kind of a general wash of all this stuff. Everything else in here is like, this is for joysticks. So I believe by default, if you just like plugged in an Xbox 360 controller to your computer or whatever controller you have, then all this stuff would just work for the most part. The only thing that doesn't work in here and requires some external stuff is like controller vibration. I got that working in a game that I made a while back, and it was kind of a pain to get it implemented, but it worked. It was in there. I just required me to download some extra files and plug them into Unity, and it was kind of a pain, but what are you gonna do? Mouse X and mouse Y read mouse positions, which is the type is mouse movement. Oops. So there's key mouse buttons, which is what we've seen. We've seen joystick axis. Mouse movement is it's going to read positional value. So if my mouse is up here, it's going to be a lower value because I think it reads from the top left. So up here is going to be a lower value on both axes, and down here is going to be a higher value on both axes. You may be asking axes. Well, yeah, because this is X and this is Y. So up here is going to be 0, 0, and down here is going to be whatever the resolution of my monitor is. So on a lot of people's monitors, if they're 1080p, then you'll get like 1080 by whatever the top value is. I always forget. But so that's kind of what mouse X and mouse Y is. Mouse X is obviously the X-axis, and mouse Y is obviously the Y-axis. So that's how you can get positional information for where your mouse is. I don't know that a lot of games use that necessarily, but that's how you get that. So jumping right in, we're going to create a new C# file, and I'm going to call it input reader. I'm going to open that up in Mono Develop. So what we're going to be talking about is how to use that input, the information we just got from the input manager, in a script. And I apologize if I'm going kind of quick. I kind of want to I want to cover all of this in a single video because I have other things in store for future videos, and this is kind of like the intermediate step between like the previous videos with arrays and the videos with physics scripting, which is what I really want to get into. So if we have this input reader, we're going to create a new game object, and we're going to put the input reader on that game object, just like we've done in the past. And when we have that script created and open, the first thing we're going to want to do is on update, we are going to make an if statement. And in this if statement, we are going to reference, we're going to be looking at the input class, which is this. We're going to say dot, and we are going to say any key. So what this means is this is the most broad variable on the input class, because again, this is a class just like we just made a class up here, public class input reader, I kind of said that this is advanced stuff, and I will be talking about it in a future video, but for now just know that this is a script class, just like this is a script class, and just like we can have variables in this, it has variables as well. And any key is a Boolean variable. We know this if we type any key, it tells us right here that it's a static bool. So any key. So if what this means, when this is true, is if there is a key being pressed. If there is a key being pressed, that's essentially what our if statement is saying, and the input string does not equal nothing. So in the input string is the, so we talked about what strings were, right? Like the string equals stuff. So this is a string, right? It's text is essentially what a string is. So it's readable text. The input string is readable text of what inputs were pressed. And the any key thing here says that we are going to be reading, if any key is down and this doesn't equal nothing, because if it equals nothing, then we're not going to want to do what we're doing, because you'll see what we're going to do next. Debug.log input, if I can type, dot input string. So as long as our input string is something and we're pressing a key, then we're going to want to log that input string. So we're going to save that. We're going to go back to this, and that's already on our object. And just for demonstration purposes, I'm going to pull out my console here, and we're going to play the game. So now nothing's going to happen until we press a key. As soon as we press a key, I just hit W, so I'm going to go Q, W, E, R, T, Y, U. So each one of those things is red, and it inputs that, it pushes that out. So if I press two keys at once, like K and L, you got to be quick, then it'll actually it'll send both of those through the input string. So if we hit 42 on the numpad, it'll do that. 42 above, well, whatever, you get the idea. It'll read multiple keys at once with the input string. This is a great way to find out what keys were pressed. So for example, if we wanted to, we could throw this in a if statement that says if input string equals W, then we can say debug.log W was pressed. So we can save this, and now, oops, the only thing that's going to, I actually opened up a new Unity. Anyway, the only thing it's going to do when we play is we can press all the keys we want. It's not going to do anything until we press W, and then it's going to say W was pressed. Another interesting thing with reading input strings is that we can say that if input.input string is greater than or equal to A, and input.input string is less than or equal to Z, then we want to say, let's go ahead and button pressed input string. So what this is actually going to say is it's kind of weird to think about it, but it's going to go through our entire alphabet. If we press an alphabet key, it'll do that. But if we press a number key, then it won't do anything. So, it didn't work. Oh well. I saw that on a forum and I was hoping it would work, but it didn't. So you can't do that, I guess. That's weird. You might be able to, but I just don't know how. I've never actually done it before. You caught me. So anyway, point is, you can do some interesting things with this. But input string is usually not how you want to read things. Usually the way you want to read things is you want to say if input dot get key down or up, or get button up or down, or get axis. Those are usually the things you want to use. So if I wanted to say get button down, and this reads two things. Well, no, this reads a string. I forgot these read strings. And the button name is going to be the name in our input manager. So if you remember correctly, over here we have, and I'm getting an error because I haven't saved my script yet, so we'll get, that's going to go away. So if I wanted to get fire 1, for example, I would have to type fire 1. And then in here we can say debug.log fire. So if we come back in here, now that I've saved that, it'll cool. So if we click, it'll say fire down here on the bottom. And I've closed my console, so let me get that back up again. Boop. So every time we press this, it will, every time we click, it'll say fire. But if we can press every other key on the keyboard, nothing will happen. The difference between button down and button up, which we've seen in here. So get button down is there. Get button, get button up. Get button down is when the key, or whatever button it is, and keys are considered buttons, which is really strange. But, well, there is key down and there's button down. It's kind of weird, but you should use button for mouse buttons. You should use key for key. Sometimes button can get keys, and sometimes key down can get buttons down. It's really, really strange, but you should use buttons for buttons and keys for keys. Anyway, so if we say get button up is when the mouse button is released, and get button down is when the mouse button is pushed down. So there's technically 3 states of a button. There is when the button is pushed down, when the button is down, and when the button is released up. And so if we say get button down, that's the frame that it is pushed down. If we say get button, that is when it is already down. And if we say get button up, that is when the frame of the button is released. So get button up and get button down are only 1 frame returns. They will only happen once, or rather on a single frame. But get button will happen every frame that the button is held down. So a lot of the time, for like a first-person shooter, which is what spoilers, this is what I'm going to be covering, how to kind of sort of make from the ground up soon. Get button is what you want to use for a lot of like your automatic weapons and things like that. So, I guess that kind of explains what that is. And get key up are all kind of going to be the same thing. So if we use get key down, get key up, those are the exact, they work the same. And there's also get mouse button up, down, and yeah. So like I said, the input system is a little clunky. These things effectively are keys and buttons. These things are just keys, and these things are just mouse buttons. It's strange and it's dumb, and I don't like it, but that's the way it is. There's also get touch. So if you're making something for a touch device, that's kind of an interesting way to get it. I've never actually made anything for touch device, but that's how you do it. There's also get axis, and get axis is that is stuff like horizontal, like that. Then we can say debug.log horizontal. So remember how I said that the oh yes you can. So if you remember how I said the input, some of the inputs are 0 to 1, or well, -1 to +1 values, and axis is that. It is a -1 to +1 value. So input.getAxis returns a float value, as we should see if we do this. It, well, sort of, yeah, see right here, it returns a float. So if we say that this does not equal 0, which is why I got an error just a second ago, if this doesn't equal 0, then we want to print out what it is. So if we come back over here, we won't get that error anymore. And I can play this, and if I push D, so I just tapped it, and I got a bunch of frames of stuff. So it started off going up, and then I believe it started going down because I let it go. So remember that there's gravity and acceleration. So what we're seeing right here is over 1, 2, 3, 4, 5, 6 frames, it was going up, and then the next 1, 2, 3, 4, 5, 5 frames, it went down. That's pretty close to being the same thing, because if you remember correctly, if we don't count the one in the middle, then it is the same thing. Our acceleration and gravity are the same for our horizontal axis. So that kind of explains what that is. And I can actually make this a little bigger so we can see it all. Axes are really, really important. They're great for like movement. They're not really good for shooting or anything like that, because you want those to be button presses usually, or key presses. I guess something that this could be interestingly used for, if you're familiar with first-person shooters, is something like a gun that winds up. So like a Gatling gun or a chainsaw or something like that. It could be really interesting to give some like acceleration to the gun so that it only starts firing once the axis is above a certain amount, and then it stops firing when the axis is below a certain amount, and that's all dependent on the gravity and stuff of the input, the gravity and sensitivity of the input. But that kind of explains what axes are. And I believe that is everything. So how do we use the inputs for something useful? Well, if we wanted to say, well, here, okay, so if our input is horizontal, then we're going to say that transform.position. I don't know that I've covered any of this yet, but this is how you move something. I'll cover this in a later video. This is just, consider this an example. You don't actually have to understand a lot of what's going on. I'm just showing you how to do input stuff. Plus equals vector 3 dot right times input dot get axis horizontal. But dot get axis vertical, and we don't want right, we want up. So what this is going to do at the moment, and we're going to not put this on an empty game object, we're going to put this on a cube so we can see whatever it is that we're going to be doing. So there's our cube, and we're going to put input reader on our cube so it's on there. And now when we run the game, if we push D, it goes to the right. If we push A, it goes to the left. If we push W, it goes up. And if we push S, it goes down. And it's the same thing with the arrow keys. The arrow keys do the same thing. So we've effectively created movement in the game through input. You don't have to understand how I necessarily did all that, because I know I haven't talked about what transform.position is, or what vector 3s are really, or what all this junk is that I just did. But just understand that what I'm doing is I'm reading the inputs. So here I'm seeing, okay, we are giving an input on horizontal, because if it's 0, then that means we're obviously not giving any input. So if we are giving input, then we want to modify the position of our object with the amount of input we're getting. So if you'll see, when I move stuff around, it kind of has like a little bit of an acceleration deceleration thing. You see that it speeds up. That's the sensitivity and gravity at work. A lot of people, myself included sometimes, depending on the project, don't like the input system, and I like to do kind of my own thing with it. So sometimes I don't want to use the gravity and sensitivity. I don't have to rely on that because it's in a separate menu from my controllers and all that stuff. It's like it's separate from my code. Sometimes I want to control all that with my code. And that's totally understandable. If you're that kind of a person, then that's fantastic. It means that, I don't know, in my opinion, it means that you like to control what you're doing rather than just throwing numbers into a box and getting random results back, which is what some of Unity is like sometimes. And the input system very much feels like that to me. I know everything in here is editable, but that's my opinion. It works really great for most things, but it can at times feel limiting because of the way that it functions currently. But that being said, in like 6 lines of code, I've managed to make movement happen in a game. So it's entirely up to you however you want to do something. If I was writing my own input system, I would be at it for a couple hours before I could probably get to this kind of a state. Maybe, I don't know how long it would take me. Depends on the robustness that I would want to do. But so there we go. There's movement. In the next video, I'll be talking a little bit about physics scripting, and that's going to feel kind of abstract and arbitrary until the following video, which is going to be about how to set up a rudimentary first-person shooter from the ground up, using the some of the stuff that Unity comes with, like the default first-person controller prefab, and that's pretty much it. But we're going to be looking at, like, okay, here's where we can put a gun model, here's where we can create bullet objects, and here's how we can Eventually, maybe I'll be able to cover health bars and how to like damage another entity in the game and how to take damage yourself. The other entity in the game isn't going to necessarily shoot at you. That's getting into AI stuff, and that's getting really complicated. But at the very least, we'll be able to cover how to create game objects at runtime, how to cast physics simulation at runtime, and how to detect when we've shot something and get shooting. That's going to be the next like 2 or 3 videos, I think. But and I'm kind of happy that I'm going that route already. But hopefully this was helpful in some sort of fashion, in some sort of capacity. The input manager is, it's great at times and it's clunky at others, but it gets you some really quick prototyping, and it's great for that. So hopefully that wasn't too in over your guys' head, and thanks for watching. Bye-bye.